Hello everyone, welcome to another learning time with Miss Blessing. In today's lesson, we are going to be learning so much about fractions. We're going to discover what fractions are. We're going to discover how to create fractions, how to represent fractions, counting in tens, equivalent fractions. Several things we are going to be learning today. I hope you are ready. Come along, let's learn together. So, what is a fraction? Do you have an idea? Pause the video and have a go. Welcome back. A fraction is a part of a whole. The shape must be split into equal parts. If the shape is not split into equal parts, it's not a fraction. A fraction is a part of a whole, and the shape must be split into equal parts to be called a fraction. A fraction has a numerator and a denominator. The numerator is the top number that tells us how many parts we are looking at, while the denominator is the bottom number that tells you how many parts there are. The denominator tells you the number of the whole parts. Now let's take a look at these fractions here. We have the shape here, and the shape here has been divided into 3 parts, and then 2 parts has been shaded. This can be written as this, or can also be written as this. So when you see it written as 2/3 like this with a slanting line, or here written this way, it's still the same. So with what we just discussed, which is our numerator, which is our denominator? I bet you already know that 2 is our numerator. Why is 2 our numerator? Because the shaded part is 2. That is the number of parts we are looking at. But our denominator is 3. How did we get 3? The whole number of the shapes. Let's count together. 1, 2, 3. The denominator gives us the total number of the shapes. Same here. This shape has been divided into 4 equal parts. Let's count together. 1, 2, 3, 4. This can also be written as this, 3/4. We always start with the denominator because it helps us know the total number of parts the shape has been divided into. 1, 2, 3, 4. So our 4 is written below. Always remember that the one written below is the denominator, which is the total number of the parts the shape has been split into. While the numerator, which is on the top, is the total number of the parts that has been shaded, the total number we are looking at. I hope this is clear, everyone. Okay, now finding half. How do we find half? Here are some pictures you could actually draw and cut out on any piece of paper you have. To find half of a shape, cut it into 2 equal pieces. Each of these pieces is half of a shape. Example here. This has been divided into 2 equal halves. Same thing you can do for these 2 as well. So go ahead, cut your own piece of paper into any shape you like and find half of that shape. Finding a quarter, the same way we did for the half, but this time we are going to be cutting it into 4 equal pieces. Each of the pieces is divided into 4 equally. Each part must be equal. Remember, for a shape to be said to be a fraction, it must be equally divided. So here are some shapes for you. Also cut out these shapes on a piece of paper and have fun finding a quarter. Okay? Now I'm going to ask you some questions showing you these shapes here. Look at the shape on the screen right now. Do you think this shape represents a fraction? Pause the video and have a go. Welcome back. Oh no, these are not fractions because each part is not the same size. Like I informed you, a fraction must be divided into equal parts. If it's not divided into equal parts, then it is not a fraction. So this shape does not show us a fraction because it hasn't been divided into equal parts. Let's have a go at another one. Is this a fraction? Yes, it is. Well done if you said yes. These are fractions as the two halves are the same size. As you can see, this size is the same as this. It has been divided equally into two. Now what about this one? Does this represent fractions? If you said no, a big thumbs up to you. No, these are not fractions because each sections are of different size. Now let's take a look at unit and non-unit fractions. I hope you are following along because I told you we'll be learning several things about fractions today. Let's look at unit and non-unit fractions. What is a unit fraction? What is a non-unit fraction? Are you ready to learn? Let's go on. So I have some shapes here, and the question I'm posing to you right now is, what fraction of these shapes are triangles? Pause the video and have a think. Welcome back. Did you get it correctly? Let's see. Remember, we always start with our denominator. So let's see, how many shapes do we have here all together? We have 1, 2, 3, 4. 4 shapes all together. So I'm going to write our denominator as 4. And remember, the question is, what fraction of the shapes are triangles? As you can see, we have only one triangle right here. So our numerator will be 1. So the fraction of triangles here, the fraction of the shapes that are triangle here is 1/4. Well done if you got this correctly. So remember, our denominator is the total parts there are, the total number of shapes, the total number of parts that is represented, while the numerator is the part we are looking at, the one you are being asked to find. Okay, now have a go at this second set. What fraction of these shapes are green? As usual, we start with our denominator. Let's count. 1, 2, 3, 4, 5. The denominator is the number of parts, the total number there are. So you have to count all the parts or all the shape or all the objects that is being shown to you to find the denominator. 1, 2, 3, 4, 5. So I'm going to write my denominator down here as 5. And my numerator is the part we are looking at, the part we are asked to find. And the question is, what fraction of the shapes are green? As you can see, we have only one green here, so I'm going to write 1 here. So 1/5 of these shapes are green. Now, what do you observe from these two fractions? What is similar? What is different? As you can see, both of them has 1 as the numerator, but the difference is their denominator is different. One has 4 and one has 5. Unit fractions are fractions with 1 as the numerator. Please do not forget this. Whenever you hear the word unit fraction, remember 1 represents units. So unit fractions are fractions with 1 as the numerator. Now have a go at this question. What fraction of these cubes are yellow? What fraction of these cubes are red? And what fractions of these cubes are green? Pause the video and have a go. Welcome back. Let's see how well you were able to solve the question. So first, I'm going to start with the denominator as usual. We're going to count the total number of cubes we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 cubes all together, so we write that as our denominator, 9. Now, what fraction of this cube is yellow? As you can see, we have only one yellow cube right here, so I'm going to write 1 up here. Now, what fraction of this shape is red? Remember, we counted our total already, so I know my denominator is 9. So what fraction is red? Let's count. 1, 2, and 3. So we have 3 right here. What about the green? Our denominator is still 9 because the total number of cubes is 9. Now, how many is green? 1, 2, 3, 4, and 5. So the fraction of the green cube is 5/9. Now, what do you observe? Which of these is a unit fraction? Did you say yellow? Well done if you did. And why is it a unit fraction? It's a unit fraction because it has 1 as the numerator. Now, what about these two? What do you observe? As you can see, their numerator are greater than 1. So what does this tell us? Fractions with numerators greater than 1 are non-unit fractions. Fractions with numerators greater than 1, like what we have here, 3 and 5, are non-unit fractions. So a unit fraction is a fraction with 1 as the numerator, while a non-unit fraction is a fraction with the numerator greater than 1. We can also use number line to represent our fractions. Example, we have a number line here from 0, labeled from 0 to 5. And as we make progress, you can see the counters increase in number based on the numbers. So we have 1, 2, 3, 4, and then we have 5. Now, if we bring the 1 closer together from 0 to 1, you can see that we can also be able to divide this number line from 0 to 1 into 4 equal parts. We can also divide it into 5 equal parts, 6 equal parts, 7 equal parts, 8 equal parts, 9, 10, and on. So we have 1, 2, 3, 4. This has been divided into 4 equal parts. And as we write the fractions, we have 0, 1/4. Why is it 1/4? Because it was divided into 4 equal parts. So our denominator is 4, our numerator is 1. So we have 1/4. Next would be 2/4. Next would be 3/4. And the next would be 4/4, which is also equal to 1 whole. Remember, when you divide a number by that same number, it always gives us 1. And if we draw our fractions below, you're going to have, for 2/4, the equal parts. We're going to have 2 shaded. We have 1 shaded here, but here we're going to have 2 shaded. Please, the parts must be equal, okay? And then here 3/4, we are going to have 3 parts shaded, and the circle must be well drawn. Don't mind this. So 3 parts is shaded here because it shows 3/4. And for 4/4, every part is going to be shaded because it tells us that the whole is shaded. Okay, let's move on. Now, what fraction is the arrow pointing to? I'm going to give you a clue before you have a go. Remember, first you need to find the denominator. And how do we find the denominator? You need to find the total number of parts the number line has been divided into. So pause the video and have a go. Welcome back. So how many parts has this number line been divided into? It's been divided into 1, 2, 3, 4, and 5 equal parts. So my denominator is going to be 5. So I'm going to write my denominator 5. So counting from 0, next would be 1/5, next would be 2/5, And next would be 3/5. So the arrow is pointing to 3/5. If you got this correctly, give yourself a big thumbs up. Well done. Now, where would 6/7 be on this number line? The number line has been divided equally from 0 to 1. How many parts has it been divided into? As you can see, we already know it's divided into 7 equal parts because our denominator is what? 7. So where will 6/7 be on this number line? Let's count together. We have 0 and then 1, 1/7, 2/7, 3/7, 4/7, 5/7. Hooray! 6/7 is going to be here. If you said it was going to be here, well done. Yes, our 6/7 is going to be right here. Okay, look at the image of the circles, read the statement and complete the table. Pause the video and have a go. Look at the image we are looking at here, this one up here. So you're going to answer the question, true or false. If it is true, you write T. If it is false, you write false. Okay, pause the video and have a go. Welcome back. How did you get on? Now, the first statement says this image represents 3 ones. Is this true or false? It's false. If you wrote false, well done. This does not represent 3 ones because remember, we start with counting our denominator and we have a total of 3. So our denominator is 3, and how many parts is shaded? 2 parts is shaded. So this image does not represent 3/3. What about this? Does it represent 1/3? No, it's also, yes, it can also represent 1/3. Why? Because one part of it is unshaded. So our denominator is still 3, and the fraction of the shape that is unshaded is 1/3. So this is true. And it is also true that the fraction of the shape that is shaded is 2/3. Okay? Alright, let's move on. Does this image represent half? No, this is false. It does not represent half. Now, counting in tens. What fraction of this bar model is shaded and what fraction is unshaded? Let's count the total number first of all. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our denominator is what? 10. Now, what fraction is shaded? 1, 2, 3, 4 is shaded. And what fraction is unshaded? 1, 2, 3, 4, 5, 6. Let's count that again. 1, 2, 3, 4, 5, 6. So 6/10 is unshaded. Now have a go at the second one. What fraction of these cubes are red and what fractions are yellow? Pause the video and have a go. Now we can use base bar. We can also use a number line, and we can also use these representations to represent a number line, to represent our fractions, pardon me. So we can use either of these representations to represent our place, to represent our fractions. So here we have a 10 frame. Our 10 frame here shows us that all of it is filled up. So we have 10 out of 10, and our bar model shows us that we have 10 out of 10 because all is shaded, and that is the same as 1. So the next 10 frame shows us that one of it is red while the rest is green. So 9/10 is shown on this table, and 9/10 is shown here as well. 8/10 is shown here, 8/10 is also shown here, 7/10 is shown here, and 7/10 is also shown here. This is just to explain to us that we can represent our fractions using anything. We can use our 10 frame, we can use our bar model, we can use our number lines. Equivalent fractions. We are asked to label the fractions and identify the equivalent for a third. When we talk about equivalent, we mean equal. Is it the same? If it is the same, then yes, it is equivalent. Now, when we are looking at equivalent fractions, we are trying to see what fractions are the same. And how do we do this? We need to divide the bar model representation into equal halves to find the equivalent. So we've been given here 1/3. Each of these bar model represents 1/3, and we need to find 1/3 is equivalent to what. And below it we can see we have 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. So each of these shows us that 2/6, we have 1/6, 1/6. 2/6 makes 1/3. 2/6 makes 1/3. 2/6 makes 1/3. So 1/3 is equivalent to 2/6. Now let's look at the second one below. 1/3 itself is equivalent to also what? This can also be further divided into 4 parts of 1/12, 1/12, 1/12, 1/12. And if we add it all together, we're going to have 1, 2, 3, 4. We're going to have 4/12. So 1/3 is equivalent to 2/6, and 1/3 is also equivalent to 4/12. Is the fraction equivalent to half? Complete the table. Pause the video and have a go. Do you think this fraction is equivalent to half? Welcome back. How did you get on? Let's look at the first one. 8/16 is equivalent to half. How do we know? Now, the total of this shape is 16, and half of 16 is 8. 8 has been shaded. 1, 2, 3, 4, 5, 6, 7, 8. 8/16. And 8/16 is equivalent to half. As you can see, this shape, when divided into 2 equal parts, we have 1, and then we have another 1 here. So we have half. And if we further break down 8 and 16, you would see that 8 can go into 16 one time, and below we have 2. 8 can go into 16 2 times, excuse me. So we have half. Now what about the second one? Is it equivalent to half? No, it is not. And the last one, yes it is, for 8 is also equivalent to half. Alright, is this statement true or false? Prove it and explain your reasoning. Pause the video and have a go. Equivalent fractions can be made by splitting the original fraction into smaller parts. Do you agree with what Kelly just said? Pause the video and have a go. Welcome back. True, I agree with Kelly. Why? Because thirds can become sixths by cutting each third into 2 equal parts. It is easy to then see that 1/3 is equivalent to 2/6. I bet you're confident with today's lesson, and I'm sure you learned a lot about fractions. For better understanding, you can rewatch the video over and over again. Please don't forget to like, subscribe, and share for more videos. Bye for now. See you in the next video.